Pilot Handbook 16.1 Navigation. Embark on the journey of cross-country flying under visual flight rules. Gain practical insights into planning and executing cross-country flights. Air Navigation Decoded. Air navigation is the art of guiding an aircraft across geographic positions while vigilantly tracking the flight's progress. It emphasizes the need for meticulous planning involving course plotting on an aeronautical chart, checkpoint selection, distance measurement, weather analysis, and computation of flight time, headings, and fuel requirements. Navigation methods include pilotage, using visible landmarks, dead reckoning, calculating direction and distance from a known position, and radio navigation, using radio aids. Aeronautical charts. An aeronautical chart serves as the roadmap for pilots under visual flight rules. It empowers pilots to track their position, providing crucial information to enhance safety. Three main charts grace the cockpit of visual flight rules pilots. Sectional charts. These are the most commonly used charts with a scale of 1:500,000, 1 inch x 686 nm. Rich in detail, they cover airport data, navigational aids, airspace, and topography. Revised semi-annually unless you venture beyond the conterminous United States. Visual Flight Rules Terminal Area Charts. Scaled at 1:250,000, 1 inch 8343 nanometer, these charts are a boon in Class B airspace. Offering more topographical details, they undergo semi-annual revisions, with exceptions in Alaska and the Caribbean. World Aeronautical Charts. For global aviators, these charts cover land areas worldwide at a convenient scale of 1:1,000,000, 1 inch x 13.7 nanometer. Similar to sectional charts, they boast the same symbols but with less detail due to the smaller scale. Revised annually with exceptions for Alaskan and Mexican Caribbean charts, updated every 2 years. Decoding Earth's coordinates, equator and parallels. The equator, a mystical circle equidistant from the Earth's poles, sets the stage for understanding latitude. Circles running east and west from the equator are parallels of latitude, aiding in measuring degrees of latitude north, N, or south S of the equator. Figure illustrates these fundamental components, portraying lines of latitude marked by arrows labeled latitude. Meridians and longitude. Meridians of longitude extending from the North Pole to the South Pole and intersecting at right angles with the equator complete the coordinates. The prime meridian, slicing through Greenwich, England, serves as the zero line for measuring degrees east, E, and west, W, to 180 degree. Coordinates in action, longitude, and latitude work hand in hand to locate any point on Earth's vast canvas. Washington, D.C., for instance, stands at approximately 39 degree north latitude, 77 degree west longitude, while Chicago boasts coordinates of around 42 degree north latitude, 88 degree west longitude. Mastering time zones. Meridians, not just markers of location, play a pivotal role in timekeeping. With the Earth completing a 360 degree rotation in a day, each hour corresponds to 15 degree of rotation. Time zones, established every 15 degree of longitude, create a standardized system. The conterminous United States observes 4 time zones: Eastern 75 degree, Central 90 degree, Mountain 105 degree, and Pacific 120 degree. Universal Coordinated Time. In aviation, the 24-hour clock rules. Universal Coordinated Time, UTC, also known as Zulu time, acts as the global reference, situated at the ODEG line of longitude passing through Greenwich, England. Pilots adjust their clocks based on their time zone, adding hours for Eastern, Central, Mountain, and Pacific Standard Time. For daylight saving time, an hour is subtracted. Navigating direction. Using meridians, pilots measure direction in degrees clockwise from true north. The true course, measured on a chart, represents the intended flight direction. Courses, represented in degrees, are measured near the midpoint of the journey. True heading denotes the direction the aircraft's nose points during flight. While true course and true heading may differ due to wind effects, corrections for magnetic variation and compass deviation ensure accurate navigation. Navigating Earth's magnetic maze. Understanding variation. Variation, the angle between true north and magnetic north, plays a pivotal role in accurate navigation. Whether east or west variation depends on magnetic north's position in relation to true north. The magnetic pole, located near 71 degree north latitude, 96 degree west longitude, introduces a fascinating dynamic. Isogonic lines on aeronautical charts, such as those in figure, showcase the changing magnetic variation across locations. Magnetic variation's impact. The Earth's uneven magnetization prompts compass needles to point in the general direction of the magnetic pole. This variation, differing by location, is diligently charted on isogonic lines. On the United States, West Coast, the needle deviates eastward, while on the East Coast it veers west, zeroing in on the agonic line. The agonic line, where magnetic variation is zero, meanders west of the Great Lakes, slicing through Wisconsin, Illinois, western Tennessee, and the border of Mississippi and Alabama. Magnetic course calculation. For precise navigation, a magnetic course must be derived from the true course by accounting for magnetic variation. If, for instance, magnetic north is 9 degrees east of true north, subtracting this from a true course of 360 degrees results in a magnetic heading of 351 degrees. West adds, east subtracts, a handy phrase for this arithmetic. Dealing with deviation. Magnetic deviation, a deflection caused by aircraft-specific magnetic influencers, requires correction. These influencers range from electrical circuits to engines, contributing to the compass needle's deflection. Deviation, unique to each aircraft, necessitates a correction known as swinging the compass. This involves aligning the aircraft at various headings, recording compass readings, and compensating for deviations on a card near the compass. Compass heading. The final step in this magnetic dance is the conversion of magnetic heading to compass heading. Deviation, the aircraft's magnetic idiosyncrasies, is factored in. A deviation card guides the pilot, providing corrections for different headings. Proper compensation is key, often requiring a technician's touch. Mastering the interplay of variation and deviation, pilots ensure that their compass points them true in Earth's magnetic maze. If you click like and subscribe and leave a comment, we will provide a coupon for a free PDF download of the book titled Pilot Handbook, or one of other ebooks. However, each individual can only download up to 1 out of 9 ebooks for free.